Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're on the road to finishing the demo. We've got very few things left. The big thing we're working on is the state machine for the geckos here because we just need to reset them when we go off screen. And they need to actually trigger the correct cleanse transition, which they are not doing. So we've spent 2 sessions now trying to fix this and we have not had any luck. So hoping we can get it done today, man. I think we're gonna stash our difference and just try to go do it again. So let's try it again. I'm just gonna I want to stash the difference here. So we made a gecko flea state, which we kind of need, right? So I think the thing to do is just to make sure we can change the state. So we should start with a gecko walk state, right? Now we need to make sure every gecko on this scene here gets a gecko flea, and we just have to make sure we pull it here. Okay, so we're giving each of these 3 geckos a gecko flea state. We need to, when we require this gecko walk state, we need to require the gecko flea state. Now, let's check out our flea state. And it's got an update. I'm just going to kill the update for right now. And then what we're going to do is just say we have a state name, so this is fine. So let's just say update gets nothing. And actually maybe update would get, because of the way the entity is actually moving, we update the entity, which looks at its direction and then updates its velocity regardless of state, which I think is the big problem here. So self.entity direction is going to get set to a flat string here. I guess we can do this here. Actually, yeah, let's do it as an empty string. I don't know what that'll look like. Yo, Duke, what's up? Yo. Yeah, good night to you too. Not necessarily good night, but you know, like a good morning. Okay, so all we're doing is just rendering the current animation. Yo, I'm doing good. I mean, I spent like an hour with Xfinity trying to get my internet worked out. They flipped some switch and restarted my modem, and now I have 0 dropped frames, so I'm just hoping that lasts. But yeah, it's been good. We're almost done with the demo. I'm just a little frustrated. It's been 3 days working on this flea state for the geckos. So it's a little frustrating, but we're chugging along. Okay, so we require it. Let's check our walk state real quick. And it should have gecko walk state. Uh-oh. We should have this thing where, well, you know what? I'm kind of tempted to comment this out and see what happens. Because know if we're doing this on just an entity basis or just on a gecko entity basis. So I'm just going to comment this out, and I just want to see what happens. Like, I want to see if geckos walk at all in the walk state, even if we're not modifying their Y position in the walk state. Okay, they don't. Okay, cool. So they just sit there. Now, what we do want to do, right now we can leave them not moving, and we can just do the thing where if they're in a walk state, where is our walk state? You know, they're in the walk state. This is what's flipping them over to the flee state. So we have to say if they have, you know, less than 0 or, you know, or 0 health, then we're going to come in here and say, well, this entity is now going to run this change state. Change state. There's a state. It's a state machine change. It's just a state machine change. So we're gonna come into the state machine. Oh no, it's on the, no, it's not a state machine change. It's on the gecko. So because there's one thing to change the animation, but then there's another thing to change the state, and it's a dot state machine. But then there's a way change, because look, we give right here. So look, we just go, okay, so if we, this is, okay, this is not how I originally thought, but see how there's a dot state machine field that is a state machine object in the entities table, and when we go to run the state machine change, we say change state, and we run that method on the entity itself, not on the dot state machine, but on the entity itself. So here, when our gecko's basically dead, we say change state, and it is gecko flee state. So for right now, all gecko flee state is going to do is print up flee state so that we can just see it. So we have a flee string as the state name. So let's go to our gecko debug, and we're going to turn on a print of the entities state machine current state name, I think. Let's see. Wow, we've dropped 0 frames. Okay, let's see. Idle. Nil. Great. Walk state don't have a name. Gecko walk state does not have a state name. Wait. Gecko walk state does not have a state name. Okay, let's see. Okay, idle, walk. Okay, let's see if we can cleanse and get into flee. Okay, well this is good. We did crash because our entity system is updating, looking for a process AI for any state. So that just means that our gecko flee state does not have that property just yet. So it's something like this, where it is a function on our class flee state. It's a function on our class, and it is called process AI. It is like this, and then we have to just define this so that the method can run the process AI. Even though it does nothing, it's just that we would crash if we try to run a method that doesn't exist. So every state in the entity has to have a process AI, because that's how it works. There we go, flee state, finally. Okay, so we got flee state, okay. So we do know that we need to change a couple of things. They're in the flee state. Okay, so that's working. So the flee state needs to boost our walk speed, and what really worries me, Duke, is like I was getting 2 megabits upload, and I call them and like, hey, I got 2 megabits. They're like, here, let me refresh your modem or something. And then it hopped up to like 50. And I told them, like, do I just need to just unplug my modem every time I go to stream? And they're like, well, it should be perfect now. I'm like, dude, you guys have never been perfect. You guys have given me months of issues. But we'll see. I mean, it's really solid. It's really solid. I mean, my camera's screwing up. Here, let me get my camera. Dude, what the heck? Why does it do this? Okay. Just made me look like Simpsons. Okay. It just gives me a tan. Okay. Whatever. Okay, we've got the flee state, so let's go over to, you know, we have to do a couple of things in the flee state, which we do have. Look at this, how we have a create animations with the cleansed gecko, not the corrupted gecko here in the animations. Once we do that, so we create the animation, I think our render logic pulls the current animation, right? So I guess I'm trying to figure out why we're pulling the corrupted gecko, because we're uncorrupted here. We do run the clean gecko anim here, so this does help, but why would it go back to a corrupted gecko at this point? I don't know. I guess we can print up in our debug, we could print up other things like if they're really corrupted or not. So we can see if the entity is corrupted. So the second value is going to be the corrupted status. Okay, they're both corrupted. They're all corrupted. Okay, no longer corrupted. You know, the particle system stops emitting, so that's correct. We don't change the animation. We don't modify the walk speed just yet, and we're not actually changing the position based on velocity just yet, but we'll add one things at a time. I hope whatever they did, like she said that this will be fixed permanently. So if it is, I would be very happy. We'll see. We haven't dropped a single frame in 15 minutes, which has not happened in a long time. Yeah, I know. They're like, oh, my bad. Yeah, we forgot to turn internet on for your house. We remembered to charge you, but we forgot to give you the thing you pay for. Well, the thing that gets me is I asked them, I said, why am I only getting 2 megabits upload speed? And they said, well, your plan is up to 35 megabits. Like, why? No one cares about the best case scenario that's not guaranteed, you know? Like, yeah. What the heck, dude? I just hate that stuff. Up to. It's like, well, 0 is up to 30. You know, they're saying, we won't give you better internet than this. Up to 30. Okay, so we're just not pulling the right animation because we overwrite the animation table. We change the state. Now, when we're in this state, we create the animation, we render. Yeah, see how could we be in the flee state and have the non, you know, we redid this. So maybe we have to change animation at this point. Because maybe the old animation was pulling from the old texture. That's the only thing I could think of, but let's see. We're just trying to change the animation to a walk right on a cleanse. So we'll try to cleanse one that is not facing right. Okay, so let's cleanse this. Okay. Oh, he cleansed. He cleansed. It was the so my upload speed, they said my upload speed is up to 35, which since I stream at 60 FPS 1080, I need like all the 10 megabit upload speed I can get. Even though Twitch caps it at 8 or 10. This is good though. This is good. The geckos are cleansing. Uh-oh. Dude, this guy's... What the... This guy's invincible! What the heck? Okay, this is very good. Yeah, my download speed is up to a gigabit, but I get like 500. Yeah, I hate that. I think it should be illegal. I think if the internet goes down for a day, I should get a prorated bill with a day off my monthly bill, you know, but they never do that. They'll just have a you know, they'll have an outage and they'll be like, you're back online. Okay, but what about the whole day I missed out where I paid you for internet? I don't know. I've got some feelings about it. Okay, the geckos are changing. We need to start modifying their position based on their velocity, and then modify their walk speed upon a cleanse, and then reset all these properties in the reset original positions method on our entities, or do it on a or it actually might be okay, because how we're doing it is we're actually deinstantiating the entities as they walk off screen, and then when we scene transition out and we come back in, it just will re-instantiate them. So we shouldn't need to reset them. They should have their own reset values if we do this right. So I think let's get our velocity moved back in, and we'll see if we can do all the changes. So our gecko walk state is the one for the logic to update. So this is a weird thing, right? I think let me check the entity class real quick, because one of the things, like when we built this game initially, we referenced some building materials from the CS50 Legend of Zelda project, and in that project all the entities get a direction to face and they move based on the direction, and that's how we built this out, based on the direction. So depending on the direction gives the proper like velocity. So I just want to see if the entity is actually updating the X or Y position based on a direction, or how the entity is doing it. So that's why I'm searching in the entity class right now. Okay, so it does have a positioning based on velocity. So we update our X and Y to be an updated value of the difference in X and the difference of Y. Okay, so this is good. So at least our entity, when we're updating it, is getting the velocity. So all we should need to change is the velocity based on direction, or I guess it depends how we implemented the AI for the geckos, because they heat seek the player. But we'll see here. I think the move is to go to the gecko walk state, and let's just turn this back on where we're saying as long as the entity is a gecko, then we ask the direction and we change, and this is where we're messed up. We just want to change the velocity. So we're not trying to manipulate the Y position or the X position, we're just trying to manipulate the velocity to either positive, negative on the X or Y. So now we should be inheriting the proper dx or dy depending on the direction. And the dx, we need, I guess we need like a, I don't know, because this would mean a gecko's walking no matter what at any time, right? Because whatever direction it's going, we might need something. Well, let's see. Okay, let's see if they walk. They should walk and chase us now. Okay, nice. Okay, we're trying to cleanse them and see what happens. Dude, what the heck? What the heck? Why can't I cleanse them now that they're walking? What the heck, dude? That's all I changed. This is what's been so confusing, is every time I try to do this, it somehow breaks something irreparably, like, and all we do is, like, why would changing the velocity change whether or not they're being cleansed? I just don't get it. If I turn that off, do they get cleansed again? Because like now they're not walking. They're in the same state. They're in the walk state. Okay, they're in a walk state. Yeah, what the heck? As soon as I try to modify their DX, they just don't get cleansed. And the cleansing is happening only here in the walk state if they're corrupted and they don't have this. So let's try this again. If we just modify, let's try to not change the animation right now. Let me just see. Like, why would just this block being turned on stop us from... Okay, let's see. They should chase us, yeah. They're cleansed, man, but this is... Dude, that's scary when they're not even turning. What the heck? They're all still corrupted, man. So we're not doing the collision because we're not hearing the sound. They're not losing health. They're not becoming uncorrupted. They're just stopping check of what's happening. Probably because well, dude, what the? They really weren't in flee state either. They were still in walk state at that time. Why, dude, why? It doesn't make any sense to me why only changing the DX or DY would prevent them from being cleansed. Why? It has nothing to do. Because when they can't walk, I can cleanse them no problem, and that works as intended. But the second I want to do anything, like, even if I just want to see something because I'm just so confused why this is happening. Like, nothing in this block should determine whether or not a thing is getting cleansed or not. It shouldn't. Should not do anything. So I'm just like commenting out what the actual code is doing, not the conditional, and then I'll just add them in one at a time and see like what breaks it. Yeah, because this is still good. So the code's there. It's just that if we touch... Okay. So look, if we try to do one thing... I guess it depends. Yeah, I mean, let's just... If we just say, okay, well, we're just going to change whatever velocity we know you're not supposed to be going to 0 and see if that changes any of the cleansing. Okay, so that is fine. Okay. So the next thing, once we turn on a different dy or dx, now all of a sudden everything breaks. I can't cleanse them. So what? Collision detection is wrong? Health is wrong? How are they not getting cleansed? They're hitting a health of 0, so they should be a flee state, and that's not happening, right? They're not going into flee state. Dude, this is what's driving me crazy over the past... This is the 3rd day now. They just don't respond. They don't have the health. They are corrupted, but they're still in a walk state. They're in a walk state. So is there a thing where, you know, well, we're changing this state if they have equal to or less than 0 heart. So if we go to our freaking gecko debug, we should be able to say, let's print up the health. And if we're getting 0 or less than 0, then we know that everything's jacked up. Then I have no idea how to fix it because... Okay, so we're printing up the health. So look, they got 2 health. Every time I hit them, they lose a health. Why? They're not even getting to 0 health. Why? What? I cleansed one. I've never been able to cleanse one. So what's going on? Can we print up the dx dy? I mean, when we render the geckos, because we're still in the walk state, when we render, we're rendering them at their own position. So we know it's not that. We know they're in the right spot because the sprites are in the right spot. It's like behaving right on the animation front. They're just ceasing to get damage if they're moving. What is going on? Only thing that was different was they were moving, you know? And this was the old logic we had. This old logic we said, well, screw the walk speed. We're just going to modify our position based on the walk speed. And this would be based on the direction, I guess. So we can... I just didn't like that approach because the issue is in the entity class, we're updating the position of X and Y based on our dx and dy in our entity update. So if we're also updating our position here in the walk state, I just thought it made a lot more, a lot more confusion. So I wanted to just change my delta Y. Let me see if there's any other time, because walk speed, is there any other time we're doing this walk speed? So for our player, yeah, we do our X plus walk speed, but this is not scaled by delta time. I just want to see how, how we do the walk speed. And then the gecko walk state is not the way to do it. Yeah, bat walk state is how to see it. Okay, so oh man, dude. I was gonna say, like, all we gotta do is do it the way we're doing it in like in the bat walk state, and what we're doing is yeah, because we calculate, this is like calculating the vector, which is something we don't need to do. But all we're doing is saying X plus the walk speed times delta time. So that's the recipe. Position plus the walk speed times the delta time. Because we have a walk speed continuous it's just, dude, the freak, it's been 3 days on this, so like I'm wanting to be done so bad. I'm so, like, it should be so easy to get the geckos to go fast once they're cleansed. Like, that's the only difference we needed. But basically we're instead of, because what this is saying our dx is now becoming the walk speed, which if we go by the bat method, what really needs to happen is X plus dx times dt. But we actually, Dude, that's gotta be so jacked up. Because the bat is also an entity, which is also applying its dx and dy. So, I mean, the other dx and dy was for, like, the bat. Flying back and forth, so... Maybe that was a bad thing to compare it to. Now, what is the entity walk speed? Because the idea is this is a walk state, and this would be based on what direction they are, which right now they aren't even going into flee state. So they should inherit this direction. So I just want to see if we give it a while to dy and dx or whatever, that if it's down, then the downward velocity is gonna be, let's just say 50 maybe? Oh, okay. Let's see. If it's facing down. Oh, yeah. See, he walks faster if they're facing down. That's exactly what I want. So if it's facing down, they're not, rendering facing down, but their walk speed did speed up. So that is good. Now, whether or not the entity walk speed is fast enough to do whatever is one thing, but let's see. dy is going to be -50. Let's just try this. It's going to be fast, but... Well, and that's the weird thing. It's like, this is making visual sense, and I would expect it to. But the issue is that we can't cleanse them when we change this stuff, which makes no sense to me. Because unless their box is just disjointed from their self, I don't know any other way that would be possible. Yeah. Okay, yeah. Okay, so the walk speed... the walk speed change does work. Okay, so where do we get... I think in our entity defs, we're giving ourselves the... Come on, dude. In our entity defs, when we go to gecko, we have... Actually, it's in a map declaration. When we do an 8.3 gecko insertion, okay, right here we give a walk speed of a 15. So we 15, 18, and 18. So I guess just right now, let's keep it like this. So what do we need to test? We need to test that they can cleanse even while they approach us. So let's just see that. I couldn't even cleanse them. Okay. So when we do this... Oh my god, where are we, man? Gecko walk state. Okay, we want to... get this appropriate speed again, but it's if we just do the walk speed here, okay, so what happens here, I think, if we do this where we say entity walk speed here, then our gecko entity's dy gets to be 18. Then in our entity update, when we do a .x update, right here, we scale dx by delta time here. So that 18 is turning into 18 divided by 60. And that's what's getting modified to our x every frame. So does that make it... What speed is that? God damn, they're fucking fast still. I can't cleanse them, dude. That's like what I don't get at all. That seemed really fast. Oh, because most of them are still 50. Let's try just entity walk speed here. Why can't I cleanse them, dude? Why? They don't get past 1 freaking health. Why? Well, it's a gecko and a successful cast. They must be updating to not corrupted or something. We're printing up corrupted though, and they're all true still, right? Dude, this doesn't make any sense to me why these guys are still not doing this. It doesn't make any sense to me. Why do they stop getting hit? Because we changed their DX. What does that mean? What does it mean? Because in walk state here, if we go back into walk state and we go to do the directional thing, and in the directional thing we say, you know what? We're not modifying our entity's dy by anything. We're not modifying our dy or our dx. And what happens? They cleanse as expected, and they change to the flee state. They render the right health. So something's just jacked up, dude. Why would yeah, dude, why would giving them a DX screw this up? I don't get it. Gecko debug. Here's what we're gonna do. We're just gonna check the debug on a gecko that is, we're gonna print up the gecko's dx and dy here. So dx is the first one, dy is the second one, and we're gonna see what the dx dy is on the non-modified version and the modified version, see if we can see what's happening. So right now they have 0. Alright, they got like a minus 40 when I hit it. Minus 40, then back down to 0. So what happens... Okay, so what happens if we turn on the running? The running is the DX adjustment right here, based on the walk speed. We should see a consistent walk speed of like 18, right? Or a DX of 18 divided by 60, which would be 0.3 or whatever. 18. Okay, so this is telling me this is wrong, right? Because 18 is the walk speed, not the dy. So like it's thinking that the dy is the walk speed when the walk speed should be 60 times faster than the DX. So the DX, yeah, the DX should not be these numbers. But why, yeah, so why would giving them these numbers change their hitbox? They're the same state, they're still walk state, they're still listening for the inputs or the collisions. We can't even hit them, man. We can hit them once and then they stop getting hit. Why, dude? Why would DX make them invincible? We're taking another look at the gecko because it's like basically if the thing has to be a type gecko and the fire spell has to collide with it and the entity has to be not already hit and it has to be corrupted for it to take damage. So we know it's corrupted. So maybe the self-hit isn't getting flushed when the DX fails to get set to 0 because we manually assigned it to be walk speed. That's the only thing I got, because that's the only thing I got is because we're overriding the DX, because normally yeah, well, so Duke, the hitbox is the actual location that the sprite's being rendered. So since they're being rendered at their own location, their hitbox is the sprite that we're seeing for them. But I think this is what's happening, because what's happening is basically I coded DX and DY to be the knockback of getting hit. And how I did it was I said, if our DX and DY, you basically, like, we detect a hit, let's say we're going to shift the character right, so we give it a positive DX so it slides right. And if any time it has a positive or negative DX, we slide it to a stop, so it kind of skids to a stop so that it slows down, right? Like artificial friction. But I think what's happening is we're hitting, but then since we're in the walk state and since we applied the DX, because remember I keep saying, why would changing the DX change why we're getting hitbox? And it's because of this and not self-hit. Because we get hit, we get a positive or negative DX or DY, we get a non-zero DX, and then what happens is our walk state says, let's update our DX to be our walk speed, which is a non-zero value. Therefore, we never reduce our skid to 0, which never swaps our self-hit to be false. Hey, Bloodscar, welcome back. So I all this to say, if I turn on the self-hit printing, I think we would become hit and then remain hit, which is not true. Hit is a boolean for it'll be true anytime you become hit and you're sliding and your momentum is still being affected by the blunt of the hit. So this is what's confusing, is that the entities were modified on the walk speed, whereas the DX and DY was changing the gecko's hit velocity, like shifting them, pushing them across the room, and then sliding to a stop. So I'm gonna print up the hit. So we're gonna see this real time here, and I'm gonna go to the walk state for the gecko. Dude, that's not good. not good. What is going on? Okay, let's try this again. Gecko walk state. Okay, I'm gonna turn this off because I'm just, well, no. We'll keep this on, but what we'll do is we won't modify our dx dy. We just won't do that just yet, because what we're trying to do, since our gecko has a direction and it's an entity class, it will be moving regardless of giving a dx here. And then once we're moving, it should also change to flee with 2 hits, and we should see our self hit go from true to false by the time the gecko stops sliding. Like by the time it's done getting hit by us and it goes back to pursuing us, then it's no longer hit. That's what we're looking for. So hit should get true as they get hit, and then slide to a false. See that? So like they're hit while they're falling, while they're getting slid back, and then false when they're not. Okay, so this is why, watch this. This is why this was breaking, even though all we were doing was changing our dx, is because of that dot hit. So if we run this again with overriding a dx and dy, we'll see that our hit never gets flushed to false. It'll just get true, and then it remains true, even though we slid to a stop. That's what I'm thinking will happen. Yeah, see, it's still hit. Exactly. That's why it's so wrong. That's why it's so wrong, because we modify the dx and dy when it's an entity class. Our entity class is just functions differently. The y is actually the, I want to say it's the walk speed. We have a walk speed. They're walking at the walk speed. So if we, well, actually, yeah, I mean, are they walking at the walk speed? They aren't walking at the walk speed. Okay, so this is why we had this. This is why we had this. The old way, right? Where, yeah, we gave it. And what I'm gonna do is just do this the old method. So we want to render the animations. We're going to keep the X position. We're going to get rid of the changed velocity and just keep the positional reassignment. There might be a way we do this with the walk speed variable, because I want to see, all I know is from the entity class, we're not using walk speed. We're using X and DX. So walk speed is like, let me just check the entity class if we have a walk speed assignment or update. No, we don't. See? So I guess the entity, I guess we want to do this where we say, well, it's weird because I feel like if we change this, our bats might get screwed up. But we want to, ideally, when we update our position, scale it by the walk speed, which we, oh god, which we do. Oh, see? Yeah, see, we just do dx dy, we don't do walk speed. Okay. This makes more sense why we had it the way we did and it was working. So that makes more sense, but it's not so great. I don't think it's too bad for what we need to do here. So we just know that we have to change in the gecko walk state. We have it set on this where it is. It's not modifying walk speed. It's modifying position scaled by walk speed. Yes, it's modifying position. Okay, so let's see the walk speed. let's see the walk speed. They should be tracking us and rendering correctly and get cleansed proper. Shoot. Okay, yeah, so he gets cleansed. Now, there is no Y position update in the cleanse. This is great. This is finally starting to work. This is great. Okay, so we need to do two things. We need to, I think we're already assigning a random direction. In this case, since there's a wall to the left, we basically want a non-left direction, right? I guess it depends how fast they fade, because I want them to skitter away and fade opacity. So let's try to just get the opacity first. So in the entity class, or I guess in the flee state, when we render, we want to set our color to be a opaque value going down to a transparent value. So what we're going to do is call it alpha, the alpha channel. We're going to set it to 255. Over time, we're going to modify the alpha to be decremented by delta time. We'll do for now. It should be a little faster than that, because yeah, it should be faster than that. But when we go to render this, we're going to do a love.graphics set color so that we can set our alpha channel. So we're going to take white, or 255 on the red channel, green channel, blue channel, and then we set our own alpha out of 255. So this should decrement our transparency once we're cleansed. And I'm gonna scale this by, I don't know, 30. We're looking for the geckos to fade to transparent, because we want like a Breath of the Wild effect where they skitter away and then disappear. Oh, look at them go! They do fade. That's cool. Okay, yeah, faster. It feels really good to not have dropped frames today. Still at 0. Nice, dude. Look at them fade. A little bit faster. Now what we need to do is basically the same thing we do in the walk. So we're going to go to the walk, gecko walk state, and we're going to pull the same positional logic. See, and this is why it'd be nice to do dx and dy so we don't have to do this crap. But we're saying, based on our direction, just modify... actually, is this what we had? Gecko walk speed. Okay. So we want to be doubly fast here. So I kind of just want to append... we'll just say... I guess for now, just try to double the speed when they run away. So they should flee and they will fade away and they will double their speed so they kind of just skitter away. That should be what happens. Okay, they should be faster and they should fade faster. They should fade faster, so this should be maybe 150. Let's see. Let's see. Oh my god, yes! Dude, that might be it. Wow, they go crazy. I don't know, sometimes they have like way too much velocity. If I hit the direction they are, if they get randomized into the direction they're facing, oh no. Oh my god, wow. I don't know, I kind of like it. I like that they skitter away. Let's take it down 25%. I think the fade away is okay. Nice. I like it. I like it. I think it's a good speed for both the runaway and the fade. So we can get rid of this. Let's check the reset status. They should reset to corrupted when you leave and come back. So let's see. So we'll just start with 1. Okay, so we cleansed him. Now we're going to go off, and he is back to corrupted, which looks right. They should always do that. I like how they run away. That looks good. Okay. And we come back, and they're all corrupt again. Okay. This is it. This is very good. Yeah, this is very good. Okay. All right. I think what I want to do, I think I want to maybe add a bit more knockback to them. Well, anyways, I think that's good. I think that's good, Duke. I think we did it. That's the big thing, is they just needed to speed up. They don't go off the DX and DY as traditional, but same with Tashio, where our DX and DY is more like our change in velocity regarding getting hit, as opposed to change in velocity with walking. So it's just something I'm figuring out as I learn how to develop video games. So we'll just continue to get better at it. It's good. It's good. Okay. Is 3 geckos good for here? Because I think it's okay. I think we should slow them down just a tiny bit. So in our entity definitions, actually in our map declarations, when we give ourselves the 13 geckos, we need to just modify the walk speed, which we'll just slow down a bit. I just don't want them to be very fast. 11 will be the fastest, and we'll do a 9 on this guy. They should be a lot slower now, which helps the player a bit, because if the player finds these guys, I don't want them to get murked by them too hard, you know. So yeah, much slower. That's feeling better. That guy's really slow. That guy's maybe too slow. I like it though. No, I think it's okay to have a super slow one, because then you can kind of analyze them. Oh my gosh, she's very cool. I like the corrupted geckos. It looks great. Okay. It's good. They get reset. They get the proper state machine. They're maybe a bit too slow, but I have fast geckos here in the dark forest, and they're supposed to kind of throw people off a bit. So there's some here, like there's one right here, and he goes fast. Yeah, see how much faster he is? So he'll chase you, and this guy will chase you too. And then I think there's a third one. Yeah, I think there's a third one over here. I didn't want to put too many. Well, especially because this guy can go through the tree, which I don't really like. But I'm not about to add AI logic to go around obstacles before we release the demo, because we are already behind schedule. But this is very good. We're done with this, which is very good. So let's take a look at her get diff, and we'll see that we about halved our walking speed. We added a gecko flea state. Oh, and you know what? We need to add this flea state to every gecko. So every gecko walk needs a gecko flea also. So let's just do that before we forget, because every other gecko needs the flea state. The other ones in the forest don't have it. So let's see if we go to change it. We'll kill the gecko. It'll have no health. It'll go to change the flea state, which it doesn't have, so it'll crash. So if we try to kill a gecko here, I think it would crash. Oh gosh. Oh my gosh. Get him. Yeah, assertion failed. Okay, so yeah, we do need to give every gecko in our map declaration. So anytime there is a gecko walk, we need a corresponding gecko flea. So we'll just continue to search through. Every gecko walk gets a gecko flea. Okay, it looks right. Let's test them in the forest. We shouldn't get an assertion failed. Now, when we cleanse them here, what the heck was that, boy? What was that? What are you... Is it because his walk speed is so crazy? Because his walk speed is crazy? Oh! I think I know. We scale our flea state by our walk speed, and these guys have a fast walk speed. So let's put this in a math.minimum wrapper, and we'll put a top speed of maybe 30 for now. Let's try... Well, no, this is just... Fuck, no, this is just the Y position. So what we're trying to do is clamp the walk speed, because we're scaling by 3 the walk speed. Okay, so we need to say if self dot, how do we do it? We need to clamp the walk speed here. So in the update or whatever, we could just say self dot entity walk speed is going to be clamped to either its walk speed. And so here is the thing, it can't be higher than 20 here in the flee state. It just can't be. It shouldn't be higher than 18 because that's the initial walk speed. That would mean the initial fastest gecko that runs off would be doubling this walk speed. So we're going to say math.min walk speed or 18 so that we clamp it. And then that should kind of reset the flee state to a baseline so that they all flee at the same speed instead of a scale factor of their original walk speed, which there was a great variety in. So it should look better now. Let's see. Dude, get away from me. He stopped walking, though. He stopped walking. Oh, bro, why? That's so... The other guys are fine. The other guys have no issues. The other guys are fine. Is it really the walk speed thing? The only other thing we do, like what? Why do they flip out? They're all just gecko instantiations. Because look, we got one here. So look, we say, you know, 8.3 has an entity with all this stuff. Where do we say the other geckos? 6.3, here's another gecko. See this? Walk speed 45. We're going to take him down to an 18. This is a 6.3 gecko. I'm going to take them all down to 18 just to check. Because these are all the other ones. If they're still way jacked up by the time they get cleansed, then we have to, I don't know. You don't need to update the gecko flea map position for each gecko? No, so what's happening is every scene you're looking at has a dot entities table, and all the geckos are in that table for the current scene we're looking at. And we're updating all the entities in that entity table based on their state machine. So since our gecko flea state machine has update its Y position with its direction, basically, then they just flee. So I do update the gecko flea, basically the entity position, based on the state machine. So they do just go in one direction. But now, so I'm just hoping we don't get any jacked up movement here. What, dude? Why did they do that? They go to like freaking... What? Why do they teleport? They go back to their original position, don't they? Because that guy was up. So why did they go back to their original position? Do we reset their... The only time we reset original positions is on a screen change. So it would make sense. Let's lure this guy over here and see if he teleports back to where he starts. So we'll try to get this guy. He does. And he screws up. Okay, so... He gets loaded at a different thing. So when he's in the gecko walk state, he should be gecko walk state, man. Gecko walk state. So look, he gets cleansed, right? We run a flea. That's why they had the right thing, right? They had the right skin. But they inherited an old position. They inherited their original position. So in the walk state, their X and Y are actually in the change to going from their walk to their flee state. They got changed. So in the flee state, we do this where we do say, well, the entity is going to get the entity, which was the original entity's position upon the initialization. So we might have to do a thing where in the update, because what's happening, you know, we're getting cleansed, so we're in the flee state. So I'm thinking that we would, you know, we're modifying the Y and X position here. So I'm thinking that when we go to modify this, it goes and pulls. Why are the animations broke though? Because I think it goes and pulls. It thinks this dot entity is what we did when we initialized it, which was the original position. But it doesn't do this. It doesn't do this for the other geckos. So I guess do we instantiate the other geckos with, well, we don't even, yeah, we do pass the entity in it. In the code gecko walk, return gecko state. So in the state machine, return the idle state. You insert a flee state. Yeah, no, I feel ya. I think I know what you're talking about. It's just when we initialize them, like the, if we go to gecko walk right here, like this, what you're talking about, where we have a flee state in here. So this is just like, this is just 3 different state machines that are going into this table. And the flee state, I don't think, you think it's breaking because it's taking another gecko flee state. Oh, there are, oh my gosh, you are right. Look at, yeah. It is pulling from an 8.3 because I copied and pasted it. Yeah, you're totally right. The flee state was instantiated with the other gecko's position. Yeah, you found it. Good job. Dang, Duke, you got like sparrow eyes. Okay, so only the 8.3 geckos need that. So that's the peril of copy and pasting, because I just have all those wrong initializations. So this 8.3 is right. So every other, let's just make sure every gecko walk has a corresponding. Yeah, good catch. Okay, that looks right. Let's see. Duke is MVP if we fix it. Let's see. As long as the animation works, right? The animation should work. They go crazy. They flee too fast. They do flee too fast. Yeah, let's slow them down just a bit. As much as I like them flipping out. Well, I think the issue is, I think down and right, they like double the speed, right? Because they already have a positive DX. Well, this would be, yeah, we modify their position by 3. Let's dump this down to a 2. Do we negate their DX and DY at this point? I think so. Let's try to I think if we negate both of these, it'll negate the super fast directions, because I think it's still modifying the dx dy from, oh my gosh. I think this will help though. Well, I guess, okay, we don't have to do this, crap. Just do it here. Okay, let's try this. Okay, let's see how these guys run. They don't run very fast, so I think I want to speed them up. I would like if their scatter speed isn't tied to their original walk speed. It's not bad. Okay, I think I want to do what we had earlier, which is we will give a higher initial walk speed, but here, before we apply it, we're going to crush it so we don't accidentally max out and break our walk speed. So I'm going to set our walk speed to a math dot minimum value between our current walk speed and maybe 20, because our fastest normal gecko is 18, so if it's faster than that, it'll get capped at 20, and then we'll put not 3 here, but 2.5, and we'll see if that's a good walk speed and flee speed. Because the flee speed is double the walk speed, so whenever we change the walk speed, the flee speed is changed unproportionally. Okay. Looks pretty good. Okay, here's the moment of truth. These guys should be... Well, these guys should be a little bit faster, actually. At least he worked. So let's go back to this guy. I mean, we have a gecko walk of other stuff. We have a 5-3, a 6-3. Let's try the 6-3. Let's try the 6-3, and we'll put a 44 in here. Make him really fast on 6-3, and we'll see if his walk speed is just absolutely absurd. We clamped it, so a 6-3 should have... this guy should have fast. 45, yeah, that's fast. And then he runs away, and he's clamped. He doesn't go freaky, which is good. Okay, so yeah, this guy can go to like a 40 also. So let's just go back. I like this. This is good. So these guys can be a little faster, and their clamp, even though it's tied to the walk speed, is also clamped. And then Duke with the clutch bug find in the state machine. I don't know how long I would have been looking for that, to be honest. So good catch, Duke. Dude, that guy's crazy fast. He's crazy fast. Okay. Dude, ow, ow, ow. Okay, we're good. Okay, I think that's it. I'm dead. I'm dead. Okay. All right. I really think that's it, actually. Let's take a look at our get diff. All right. So we gave all of our gecko instantiations. We gave gecko flee states with the proper parameter, thanks to Duke. We are not modifying our dx dy in the walk state, we modify our Y position. I don't like that. It's just a byproduct of how we've been doing the DX and DY with entities. So it's going to have to suffice for now, but it's going to be add flee state to geckos. Other than that, for the demo, we're so close to done. We have 2 or 3 NPCs we've got to add, right? We've got to put somebody in the Pokemart, I'm calling it, and then the gym. It's just a building that are over there. Maybe one person in the flower bed in Main Street or at Main Street. And then maybe someone goes in the refinery for tooltips. They might have state machines, they might have animations, they might just be facing one direction depending on who they are. So I don't exactly know what that'll look like, but in terms of the demo being ready, we have very few things other than, we'll have the play test and stuff. The big thing is going to be to merge back into our main branch with all of our saving and loading and make sure none of our bits or stuff broke on that split, because it's been like 20 commits off that branch. I'm not too worried about it, but let's run credits here. We'll call it a night. Thanks for watching, everybody. We'll find someone to raid out to, and I'll be back tomorrow with more game development stuff on the road to finishing the demo. We should be done. We should be done soon. We really should. I mean, I'm gonna, who knows how tough we're gonna find some bugs, but we've been pretty good about hunting bugs as we find them, and there's none that I'm aware of that are totally game breaking at the moment, so we'll see. We'll see how it goes. I cannot see who's working on game dev stuff. We're looking for it. Year end is on. Yeah, done with gecko bugs as far as I can tell. It's good. It's good. It's good. Yeah. I guess, we'll hit up year end. Oh no, he's playing something. I'd like to try to find someone programming. Oh, we finally dropped some frames. Okay. We're looking for I don't see anyone programming. Okay, well, we'll just raid out to somebody, because we'll raid out to somebody. Alright, well, thanks for watching. I'll be back tomorrow. Peace out. Thanks for the help, Duke. I'll catch you later. Almost done with the demo. Thanks for hanging out.